Okay, good morning, everybody. It's my pleasure to receive three panelists today, and I will actually ask each of you to introduce yourself in like a couple of minutes and tell us who you are and what you're doing. And maybe as a way of introduction, in this panel, we'll try to sort of follow up on last year conference where we did present a few vessels, or let's say a few concepts, and try to update the audience on where are those projects going. And we've three panelists with us. Maybe we should start with our local panelist, Andrew, up on the Hudson River, New York.
Hello and thank you. I hope everybody can hear me. My name is Andrew Wilner, and I'm the Executive Director of the Center for Post-Carbon Logistics. And our organization is an advocacy organization for post-carbon transportation of people and goods by water from place to place. The center envisions a world of resilient, relocalized communities connected to one another through post-carbon transport and logistics systems. And our mission is to research and assist in the implementation of appropriate post-carbon maritime technology needed to keep commerce and transportation viable by responding to the interrelated connectivity, communication, equity, economic, ecological, and energy crises of the 21st century. My job, as I see it, is both to be involved personally with projects that are being developed locally, regionally, and throughout the U.S. And my partner and I, my wife Joellen, have been partners and investors in the Vermont Sail Freight Project, the earliest sail freight project on the Hudson River and the canals. And we are also supporters of investors in the schooner Apollonia, the present cargo carrying sailing vessel on the Hudson River. I also was recently one of the sponsors of a regional sail freight conference that was held in Kingston, New York last Saturday. And I think it was an extraordinary success, and we had an amazing dialogue, and huge ideas were shared, and an enormous amount of progress has been made. We also are extraordinarily aware of the problems facing both very large and very small builders and operators of alternative fuel and sailing freight vessels in the foreseeable future. But we're amazingly hopeful based on the feedback we got from the conference and by listening in on this conference as well. Thank you.
Yeah, thank you, Andrew. And indeed, we did participate to this conference last Saturday, really about, let's say, short sea shipping or river shipping. A lot of projects popping up here. Very interesting conference. And Andrew was our first guest on the podcast, Hoisting the Sail, about 18 months ago. And this episode still has the best audience. So if you really want to, it was an eye-opening podcast interview for many of us. So don't hesitate to listen to it. Thank you, Andrew. Roger?
Yeah, so my name is Rogier Eggers, or just Roger for short, indeed. I'm with Marin. I'm here a project manager, formerly into maneuvering of ships, doing scale model tests in our basins and simulations, but since about 10 years, increasingly involved and now involved in most work at Marin regarding wind propulsion. Also, they are doing a lot of research work as well as applying it in the first projects that you see emerging in the water at an increasing pace. Some of the public shared projects that I'm involved with at Marin is, for instance, the WISP joint industry project, where we are trying to improve prediction methods, helping a more smooth transition through EEDI calculations, more fair regulations. At the same time, we recently started the Optiwise EU-sponsored project, but the publications of that will be shared internationally, where we are looking into really rethinking ship design and operations with a view to make the best use of wind propulsion. So really stretching it away from the retrofit that is still the mainstay of most projects. And then I have a seat in the ITTC, International Towing Tank Committee, Wind Propulsion Committee, where we're trying to formalize standards. So a lot of hands-on work on wind propulsion, trying to help the industry there in one of the solutions for decarbonizing. Thank you.
Thank you. Guillaume?
Guillaume Gaillard, a colleague of Roger at Marin Institute. For those who were here yesterday, then I present myself already at the session of yesterday. I'm heading the ships department at Marin, being involved since 15 years in promoting technologies around zero emission and in particular wind propulsion, and also part of the let's say European Commission group of experts around wind propulsion and zero emission shipping.
Thank you, Guillaume. I'd like to start this panel discussion with maybe one of the ships that is drawing attention today. It was launched on the water maybe, I don't know, 3 months ago. I think it's currently somewhere in the Netherlands being equipped. I'm talking about Canopy, which is a hybrid RoRo vessel that will carry the Ariane Group rocket between Europe and French Guyana. It's a hybrid vessel with wings, solid wings from Ocean Wings. It was launched again about 2-3 months ago. Would Roger or Guillaume, can you maybe tell us more about the ship, what makes it sort of unique? Where is it now? What will happen in the next few months? And again, you're not the ship owner operator, but we value your sort of expertise, and also being sort of in Europe. I'm sure you can help us on this. Thank you.
Well, maybe just before I give the words to Roger, who's much further than me, especially on this topic, I could share my screen because I have just a view of the ship you were mentioning, and that could illustrate the purpose going through. Just for the audience to tell what we are talking about in terms of ships. Is that okay? Should I do that?
Yes,
sure. Yes. Okay. Then small manipulation and Rogier, maybe the floor is yours to discuss about that technology.
Yeah, I'll follow up. But
you were talking about that ship, Laurent.
Yes.
Yes. Okay.
Okay. Sorry, you just put it on the screen and then
yes.
to start. Yeah. Okay. So the question, you put us a little bit in a difficult spot, in the sense we're not the owner or the developer of this project, but like you mentioned, we have good contacts in the industry, and including with Aero, who is the supplier of the sales system, and Zephyr and Boré is one of the leaders of the project. You mentioned it has been launched in Poland, where roughly put the steel work was done. Dutch shipyard Neptune Marine is now finishing the ship, so the ship is in the Netherlands. I am not familiar in a lot of detail on the schedule, but I believe it will be fully completed somewhere in the spring of next year. So yeah, this is one of the landmark projects in the sense that the ship has already been designed to a large extent to take the wind propulsion and sail at an optimum efficiency, really beyond many other projects in that sense, and it will really start sailing. And as you have possibly have seen in other media messages, the leader in this project, Safir and Boré, they are developing a follow-up project where there is also some publicity already being shared, but so we can see follow-up of this concept, and yeah, I think that's as much as I can say here.
Yeah, it's well, just for me, because that was also last minute preparation for you, Roger. But I prepared a few slides also to show different types of concepts running at this moment, and let's say from the most recent one, which are or selling already or under constructions, up to more, let's say, expected solutions. But what we see overall, and that is important compared to, I think, 10 or 5 years ago, is that the suppliers in this sector are becoming extremely mature. So there's a harsh competition, of course, because everybody goes. It's not like plane of let's say wings of an airplane. There's no yet conversions to one system. There are many systems that are developed at this moment, all making use of wind and lifting surface basically. But some of them are allowed to have different sizes. They're also retractable, foldable. And I would say at this moment, there's a bit of test for everybody in terms of complexity, power, performance, scalability, probably price as well. But this part we do not sit in. But still, despite the very large number of systems which are proposed at this moment, it's only a handful of ships who are equipped with this type of systems. So we are still far from, let's say, a harsh competition between every suppliers, because there are a few 10,000s of ships to equip and also new ones. But it's very good to see, let's say, a flourishing of ideas or concepts. And I would say that all of them went the last 5-6 years from, let's say, prototyping up to really, let's say, solid engineering process solutions, and hopefully they will keep their promises when they are installed on board ships as well. So if you'd like, Laurent, later I can also, let's say, go through different image showing, illustrating those, but also up to you to decide when you want us to comment on it or not.
Yeah, maybe let's push a little more on the canopy. One question for you I have is what about the air draft? Because I think that's a common question here with a sail like that. What impact will those sails will have on operation, access to the port, going under bridge, and so on?
Well, yeah, that question is, of course, very much ship specific or ship type specific. The Ariane cargo stream, even the ultimate version, because it has a really rather strict operational profile, as I understand. But talking more generally, let's say I recently delivered a paper for the Prats conference where we did a case study on bulk carriers. On a ship like that, you have very common constraints on loading ports that have relatively not so far extending cranes, but where you have a lot of dust falling on the deck. And unloading ports have gantry cranes that may extend over the full beam of the vessel. These kind of constraints can have a large influence, and passing under bridges is another one, of course. If you want to pass through Suez or Panama Canal, then you can't have an air draft or fixed air draft larger than some 60 meters, 60 meter plus. So you need to go in folding or retracting systems, which does add to the cost. However, at the same time, we see that most suppliers do have solutions for these matters. So of course, it does limit the positions where you can put systems, but the solutions are in the market to deal with such constraints.
Yeah, and I believe, let's say for this, I mean, the concepts are evolving every 6 months, so it's, I mean, we made a selection here just on public photos, so it's going very quick. You see already on that principle that the sail is foldable, so that would reduce the drag in headwind or no wind conditions. But I thought also that there was a system now developed to be also tiltable. There was here another illustration on that one of one of the precursor, Norse Power with Flettner rotors, but you also have an Amoy working on the same principle. And I think there's now a third and a fourth player also presenting cells based on Flettner rotor. I mean, you see on the photo here that the latest version has also been designed to be retractable to go on the bridges. Well, the figures, the photo says it all. There's a ship sailing under a bridge. So you see that the suppliers are quickly adapting to, I mean, they don't have yet large orders, let's say in terms of hundreds of ships to be equipped, but they are moving extremely quickly, very often because they are young companies, startup companies, and they are moving extremely fast in adapting to the needs of the market. So foldable systems, tiltable systems, even for Flettner rotors. But basically all the systems so far are proposing this type of options. The only ones so far that were also precursor on the market, these were the Dynarigs, where I just put an illustration here. Those were used on two very large yachts. So these are not small ones. You talk about 120, so 360 something feet ships, but they were not able to make a let's say retractable tiltable mast. Some of those ships well are selling actually since few years, so the technology you could say is ready, but there's also some commercial version, and there might also be some engineering to do to have it retractable. But again, there will be also a lot of niche markets. So some ships sail between harbors and there's no air draft restriction. So they could also fit the picture. Well, also another example here, that is the project of Neoline that has started with different types of sails. You've seen that the latest version, which is now envisaged, so far that we know, is with a solid sail. That was also discussed yesterday during the session. And this system also has evolved. I mean, it exists as a prototype now in the harbor in Nantes on the quay, but they're testing the complete system. And this system is also foldable. So you see that there's really a trend at this moment to, let's say, every sail has its own specificity with corresponding performance and amount of power that it can absorb from the wind and thrust. But they're also, so they all have their, let's say, complexity and type of profile, but they share, let's say, a common aspect of foldable aspect or tiltable to ease entry in as many harbors as possible, also with air draft restrictions, but also to ease and to allow safe maintenance or, let's say, harbor operations for cargo.
Yeah, we see, if I may add to that, if you allow me, Laurent. We see the Dynarig now also, of course, entering in a commercialization stage with sail cargo, intending to use that rig on their concept. Further, I think maybe an interesting distinction that you can draw between the different solutions is the efficiency of the rigs, and I mean the lift over drag ratios. So we see basically the large systems like the Dynarig, like also the solid sails, like the wing sails. They operate by maximizing the sail area, basically. Therefore, they can operate at a lower lift coefficient, which means they induce less drag, and that makes them generally, and this is of course a generalization, including indeed this Zephyr and Boré concept with wing sails from CWS. It makes them suitable for higher ship speeds or ships operating on routes where the winds are often from the bow quarter or close hold conditions. Whereas, let's say, the active devices, so that's mainly the flattened rotors and the suction wings. They have the concept there you add power either in rotating the flattened rotor or in sucking the boundary layer in a suction wing. They can generate much larger lift coefficients, so you're able to use a smaller package on deck to deliver the same thrust. However, they come generally with this high lift, also with a larger drag, which makes them less efficient in ships that are sailing faster and that have the dominant effective wind, apparent wind from the bow quarter. Yeah, and then we have the retractable system indeed of the Wind Challenger project, also in a very advanced stage and already sailing. It's had a long track record of research leading up to this, but I think very promising technology in the bulk shipping.
And maybe on the Wind Challenger project, most of the project you've presented are sort of European based. This is in Asia, correct?
Yeah, that's correct. Yeah.
And exactly, and of course there's another development already sailing for some 4 years maybe already, Dalian Shipbuilding with their twin retractable wing sail looking rather similar as this one. New launchings are announced for that technology. We've seen a flattened rotor manufacturer Dongfeng becoming active, not yet launched their project, or no tangible prototype yet installed, but we see activity increasing in Asia. For a long time it was mainly Wind Challenger, but we see another projects emerging, and I think there's probably more behind the scenes that we didn't see yet.
Yeah. That was a bit risky for me actually to put some designs, because of course I forget many, and good Jorge that you mentioned the suction sail, which was based on the Cousteau ship suction sail from the year 70s, and which is active again with two companies working on it, and already one Econowind proposing already let's say a containerized version of the sail that can be put on the deck and extended. So the presentation I did, and I have a few more slides, were not intended to cover the whole market, but to give some illustrations. But good to make the difference between the systems who are using, let's say, rigid profiles to try to optimize the lift, and the rigid profiles are difficult to, let's say, to collapse or to reduce. And then you have more, let's say, kind of semi-rigid soft sails that can have a mechanism to be folded. And then you're going to the active systems who requires energy, like flattened rotors or suction sails, who are trying to, let's say, with mechanisms to improve further the lift while reducing the size of the unit.
Yeah.
Then the only solution we left out here is the kites, which are a bit of in terms of physics different principles, using maneuvering in the air to increase the apparent wind angle over the kite. Also very promising, with a very limited footprint on the deck, just on the bow. Yeah, you can achieve large propulsion. However, this maneuvering in the air is only really possible in a more narrow spectrum of wind angles than the other sail systems. So there's again disadvantages and advantages. And I would say, looking at all these solutions, even after the industrialization phase, Taking, for example, this ship speed effect, that some faster ships, they will tend more likely towards wing seal type solutions, slower ships maybe to suction seals and flatten rotors. We expect that there will remain a place for a multitude of concepts out in the market.
Yeah. Well, and just to relate on that, because I also put actually a picture of one of the latest development also with inflatable sails. There's some small prototypes working on sailing ships. They are planned to make really large structure. This still needs to be checked and tried, but you see that I mean, creativity has no limits, and at the moment that we keep the same physical principle of transforming wind into lift with a minimum drag, then well, there's a long life for concept development. So I think that in particular should be quite interesting for the students at the web and all the engineer students to see that there's an incredible amount of concept to be developed, and likely I guess that over maybe 10 to 15 years, when there will be a lot of implementation on different fleet, there will be a kind of convergence towards better and better systems, but there will never be, I think, one size and one concept that fits all, because many ships have different constraints, different types of operational conditions, and mission profile, ship speed. So there will likely be, like we have a multitude of type of propellers or different types of propulsion systems, propeller, water jets, boats. They will also be for sails, likely for this type of power. We talk about also quite a diversity of solutions, and hopefully, because every owner and every yard will be able to find the solution that fits their requirements.
Yep. Yeah, thank you for that, Roger and Guilhem. I like to bounce back on the keynote address yesterday morning by Paulo from Tufton on like the stakeholders in the, let's say, the whole supply chain that are getting involved into the decarbonization, and on the wind projects, wind propelled projects. There are quite a few projects really initiated by the cargo owners. One of the very striking ones is maybe not a new ship, but Sail Cargo recently acquired Vega, which is an old ship. It was built in the 1800s, but a coffee maker out of Canada is a big partner of Sail Cargo, and basically he didn't want to wait for the vessel to be ready, so helped Sail Cargo to purchase, restore, and get the vessel ready so they can, as soon as early next year, transport coffee beans from Colombia to New York. For me, it's quite a big, strong signal from the cargo owner saying, we're ready, we don't want to wait any longer. And Andrew, I'd like to get your opinion on that. How do you think the cargo owners are ready? The consumer, how do you see that moving ahead?
Well, thanks for asking that question. We have some challenges both in the Hudson Valley and the U.S. because of the United States unwillingness to subsidize these innovations, and for the state of New York to not be including waterborne transport in their climate action plan to the extent that it should be. So instead, what we've done is we've developed a regional consortium that is made up of ship owners, cargo distributors, farm goods processors, and makers and small manufacturers. And so far, the schooner Apollonia, which is the only one operating on the Hudson River, is developing these relationships with the people who make or want to move these cargoes. A couple of examples are a relationship with a pepper farming project near Newburgh, New York, that's shipping its produce to Hudson, where it's processed into hot sauce and then carried back to distributors. So there's an interest on the part of brewers because Apollonia is carrying malted barley. There's an interest in terms of farmers and farm products producers because they're carrying both the raw and finished products. And I think it's being driven to a greater extent than one would think because of the people who are producing and manufacturing the cargoes that are likely to be carried on the ship. It's been successful enough, and Apollonia has done what it can with the capacity that this same consortium has thought about and is now developing a new vessel that's going to be purpose built for this route and for an extended coastal route. And we're hoping that this vessel that's been designed by Jeff Utmark, the Erie Max RSS 80. So Erie Max, meaning this vessel will be both an Erie Canal, Champlain Canal, Hudson River Harbor, and coastwise vessel. And it's built as what Jeff has described as a ship kit. And if you have a second, I can share just something, and I hope it's an appropriate. Let me see if I can share the screen. Can you see that?
Yes.
Okay. So the ship was designed originally in 2015 specifically to carry wine from the Finger Lakes in New York to New York City, and also to carry wine from Eastern Long Island to New York City and the idea was that vintners would get together to supply the ship with cargo in both directions. And what we're finding is that because of the versatility of this ship, the fact that it has sails and tabernacles, it has 2 electric motors with battery and solar panels, and it can be expanded or contracted based on the need. The construction length of the vessel can be expanded and contracted depending on the specific need and Coast Guard regulations. And so we're hoping that over the next year, we will raise the capital necessary to build the first of many of these, what we're calling Liberty ships for a carbon-constrained future. Many of you know that during World War II, the United States took a World War I British ship design, and by the end of the war was producing 4 a day, and in less than 40 days. Each ship was doing less than 40 days. We think that the same thing could happen with a design like this for the climate crisis. I don't know if that entirely answers the question, but cargo is definitely driving the ship designs that we're looking for short sea shipping and river and canal work in the eastern United States.
Yeah, thank you for this, Andrew. It does definitely highlight the cooperation, broad partnership between the shipping industry and the cargo owners. Maybe good segue to two companies in Europe announcing actually the construction of new ships. I'm thinking about Grain de Sail, which has built and launched 2 years ago the first modern cargo sailboat, 72 feet long, carrying 50 tons. And they basically leave France, bring organic wine to New York City that we really love. They sail down to the Caribbean, to load cocoa beans that they bring back to France. They are a chocolate maker in France and also a wine exporter, but their main business is really making wine. They announced a second boat that construction started actually maybe 6 months ago in Vietnam. It will be launched in the 2024, I believe. Capacity of, I think, 350 tons pallets carrying, but really offering quite a few opportunities for cargo owners to ship across the Atlantic at zero emission. And the second company I'm thinking about is TOWT, Transoceanic. Thank you for the Transoceanic wind transport, obviously. Again, 2 vessels are currently being built. They will do transatlantic across the Atlantic and route, let's say, into the Atlantic between Europe, North America, Central America, Africa, on different trade routes out there. Any Guillaume, Roger, any comments on those 2 projects?
Well, if I may start, because I just put these 2 photos together. What you mentioned is really interesting, because you see that some let's say cargo owners or companies decide not to wait and start. So you see in both cases the rigs are quite traditional. So they are using, well, I mean, I should not say that they're also quite advanced, but I mean, it's just existing technology with a part of automation as well for the handling of the cells. But this is just a low risk, just mature technology to propel ships. What is interesting is that the initiative is coming from companies which are not very large. I mean, I don't know about project TOWT, but for example, the other one that is also designed made by Zephyr and Boho, it's not yet. I mean, I think the order has been confirmed, but I don't know what it will be built. I don't know about that. But Arcady, the company which is after that, it's a company of 120 people. I mean, when you think the amount of let's say the power, the organization of companies like Philips, IKEA, you could say as well Tesla, or also moving cars around, or UPS, and name it, or Coca-Cola, then you could say, well, they could have the power to try a few of these ships to move their cargoes around. Now what we have really companies which are not so large. I think Arcady is doing like something like 25 million euros turnover per year, 120 people. They are really sitting on a very niche market. They are selling bioproducts coming from Indian Ocean up to. Oh, sorry, there's a Larsen now. Okay, sorry, I heard my voice. So they are selling just. They want to bring their product from one part of the globe to the other without impact, so zero emission. And well, they accept, I would say, you could not say they take the risk because this is existing technology, but they decide to move on without waiting that it is just mainstream. And they have the capacity to do it despite their relatively small size compared to very big players. So I would say if those companies succeed to do it and can try it, then many others should be able to, let's say, follow and take the example and do that on a larger scale. So there are typical examples where people don't wait, they go ahead, they will see a direct benefit, probably in line with the type of product they're selling. So again, quite a niche market. But these type of activities are changing the landscape of transport, for sure. And Roger, I think you wanted to add something.
Oh yeah, I think you highlighted a few. If you look on the website of New Dawn Traders, they have Silk Cargo Alliance listing many of these projects, let's say on the smaller scale. They have some 12 projects on there, of which some of them have by now not one ship but multiple. So this fleet is growing. And many of these smaller projects, they really have a close relationship with cargo flows, cargo owners that have some buy-in into the project to make it exist. And by contrast, maybe some of the suppliers more on the industrial scale, larger scale, have been up until now, up until recently, many were, let's say, idealists also, but taking it more from a bigger industrial perspective, trying to promote their technology rather than approaching it from the cargo owner side. But these things, in some instances, they're meeting each other. For instance, I would say, and that's a bit of an interpretation, but CMA, CGM, taking a stake in the New Align project to give that the final push into realization. You could say CMA, CGM, really established player with the cargo network, and then embracing a very ambitious project to make it work. So, and I hope we increasingly get to see that these two worlds are starting to meet each other to increase the impact.
Yeah, and maybe to bounce back on that, the project we saw with the container ship with SAIS, they created actually a co-op of suppliers from the Ocean Indian, basically to move goods and being able, because Arcadie, at the origin of the project, is shipping maybe, I don't know, 50 tons a year or 100, but very, very small cargo somehow. So they decided to look for other cargo owners, and were able to basically put around the table enough people to then work on the vessel, finance that. And I know the co-op model is something that Andrew has been sort of promoting and pushing. Is that a sort of similar approach on the Hudson Valley that you're taking here, Andrew?
I'm sorry, could you just ask the question again?
No, I'm saying that this model, WinCop, is really a cooperative, a co-op on one side with cargo owners, but also manufacturers, cargo users somehow. And I think you do promote on the Hudson Valley quite a similar approach. So that's sort of my my question or my suggestion.
Right. By necessity, because our efforts at this point are really nascent, we have to have a consortium of like-minded individuals, organizations, institutions, and businesses to make this work. And so far, it has been the efforts of very tiny companies that have made significant strides despite the lack of large financial backers. So we want to take that to even a next step and start thinking about what we can do with having community co-op financing for these ships. In other words, the ships will go back to the old concept. Well, not so old. Well, the concept from the Middle Ages in Italy, where 64 shares were sold in a ship, and the ship was really owned by those shareholders. And we want to modernize that idea under another one of Jeff Utmark's brilliant suggestions, which is he's now calling ship shares. And the idea is that a community can be manufacturers, like they did in Brittany for the ferry company. It could be farmers. It could be a community of like-minded individuals. It could be a literal community, a town. When the Erie Canal opened in New York, almost every town in southern Lake Erie built its own schooner to transport goods coming from the canal throughout the lake system. So we're hoping that cooperative nature and that cooperative enterprise model is going to be the way forward, certainly in the Hudson River, and we're hoping throughout the U.S. We also think that the idea of building this ship kit, something that can be replicated open source in any yard that can competently build a ship of this size, will give the community in which it's being built a stake in how it's used, how it's financed, and what products will be moved.
Thank you, Andrew. Guilhem, Rogers?
Yeah.
Yeah, to respond to that, your answer, Andrew Wilner, reminds me of the Green Heart project. I think trying to do something very similar with a simple design at that time really focused on the Pacific. Unfortunately, maybe this project was a little bit too early in its time. It didn't really get traction and no ships were built. But question back to you, did you have a look at that project? And I believe there's even designs that could be reused possibly.
No question. My interest in this goes back to the 1980s when the Japanese were retrofitting ships with sails, and a colleague of ours built what he called a tuggantine, a schooner rigged tugboat in Norfolk, Virginia. Yes, we're very open to the idea that open source design can really be the way forward for certainly for smaller ships, 100 deadweight tons and under, because they can be built in small yards. And some of these ships can be built by skilled home builders, and I think that may be one of the different approach than the very large industrial size ships. And I think the more small ships we have in coastal trade, in river trade, and solar vessels on the canals to feed those transatlantic or New York to Caribbean routes, Apollonia for the first time in the last 4 years picked up fair trade green coffee beans in a small port in Carteret, New Jersey, and brought them back to Hudson Valley Roasters. The next connection we need, obviously, is that ship that's going to be bringing fair trade coffee beans to New York, so that Apollonia or ships like her can then distribute them regionally. So I think that Green Heart was revolutionary in both its concept and its ideas, the same way that the Sail Freight Vessel series was. I mean, this was literally a farmer who built a sailing barge in his backyard, but it was a total success in both concept and execution. And it was a lack of funding at the time that just kept him, and a tired captain who's also a farmer who just couldn't continue to do the work. So I think we really have to concentrate on the idea that we have two ends of this spectrum. And fortunately or unfortunately, what the work we're doing in the US and in the Hudson Valley is at the smaller end of the spectrum. But I think that's just as important as the larger industrial size ships are being conceived and built.
Fully agree with that. Yeah, and I'm not sure about the traction going forward. I personally, in my work, if you allow me, Laurent, to elaborate on that, I think finally on the larger end of ships, of course, that is where shipping is really efficient, the economy of scale. And you can argue, do we need as a world that much transport? It probably needs to reduce if we really want to reduce our carbon footprint. But if we want to keep some resemblance of the economic efficiency, transport flows worldwide, we need these bigger ships. And on that front, there is still a lot of development work to do to scale up solutions, also in production capacity and finance and regulations. Those matters are still leading to cost in the big rollout of projects. We have a big push with the EEXI regulations, where a lot of ships, when they come up to certificate renewal starting in the 2023, many of them are not compliant. They need to do something. This is a big push for many wind propulsion solutions. But then going further, EEXI is not as ambitious to deliver the IMO ambitions of 50% reduction of carbon emissions. We need more, and there's work to do.
Well, If I could add a small thing on that, because I see, let's say, I fully agree, and nice to have your input, because I think on the two sides of the spectrum, something is happening on the local side. So something not against globalization, but more to say, well, locally you can find solutions. There were the example of Fiji Islands also relying a lot on fossil fuel for transport, while they have just enough wind capacity to do that themselves with on local resources. So you would have on the one hand of the spectrum niche markets, small markets that can be more, let's say, self-standing and using local energy like wind to make a network of transport. And on the other side, what I see is that on large scales, cargo owners and ship owners are also moving their own path, because I'm not sure that everybody realizes, but there's a kind of revolution happening at this moment. A bit what happened, I would say, in the car industry the last years. But the role, the definition of roles of each stakeholders is evolving very quickly. Used to have ship owners and then energy providers, harbor infrastructures, but they're not moving at the same pace. So you see really the other end of the spectrum that Maersk announced that, okay, they have selected a given type of energy now. Well, that will be the future one or not, but green methanol. But they're clearly saying that they are not able to move. They are moving just quicker than the energy sector and infrastructure. So they are moving from their position of ship owners, and they are making now partnerships to create their own network of supply of energy. Because they say if we wait the energy sector to do that, we will never have things on time. So you see that people take their responsibility on both sides of the spectrums and try to organize their future work themselves. You have the same thing with CMA, which is investing in self-propelled ships. Of course, that will be a small part of their total volume, but they are not waiting that happens. They just take the responsibility. And I would say on one side, on the consumer side, there's a movement happening. On the ship owner, cargo owner side, it's a lot of things happening. And on infra and energy side, let's say the traditional energy suppliers, things doesn't move as fast as it should. So you see that on both ends, just people are now making plans, taking responsibility, and don't wait for the rest to move. And I mean, they will follow, but the traditional sectors, I would say, that have been promoting for a large part innovation and new things and are just waiting, lagging behind, maybe because of their very large maturity, so they don't have to move right now. But they are becoming followers, and it's quite a revolution at this moment. What's happening in the transport sector?
Yeah. Thank you. I think it's a very good conclusion. I will indeed just concur to that. But some cargo owners really, I think, want to take more ownership, control of their supply chain, and the initiative by Michelin to call for a tender to build a container ship crossing the Atlantic. It's one departure a week from Europe. It's going to be 10 vessels, one route Northern Europe, US, another one Southern Europe, US. And the tender was, you need to carry 500 TEUs, you need to be able to harvest wind, and you need to reduce emissions by 50%. And that requirement came from the cargo owners, and shipping companies did bid on that. There's one in the room, he might not be there, but a former Web alumni Seychelles did a bid for that. Again, it's to illustrate what Guillaume is saying, like responsibilities are shifting. The cargo owners want to take control. Shipping companies want to take control of the energy provider somehow, or get more involved. Anyway, we're reaching the end of this panel. Any questions in the room? Yes.
Philip Colonna, student and also from MTIRA. So we're talking about the large end of the size scalability. My question is there something, especially in regards to things like mast or other wind device structural design, is there an upper limit to this? Or could we theoretically have a 24,000 TEU ever a lot sail, or in the ultimate irony, a 560,000 deadweight ton Seawise Giant sail? Is there an upper limit to how big you could build a sailing vessel?
Well,
How do we want it?
Well, I'm definitely not the one qualified to answer that, but I might be able to sort of oversimplify. I think harnessing the wind doesn't depend on size. Any vessel could harness the wind, and a naval architect may disagree with me, but I don't see many reasons why not. Now, wind being the main propulsion, there will, in my opinion, there might be a limit there. But Guillaume and Roger.
There might be some constraints on air draft, for example. There might be some constraints on a total amount of power needed and redundancy, because I mean you also need to think about all the systems, auxiliary systems that needs to function also for maneuvering. But I mean the limit is not yet known. I mean I think there's a same that like for wind turbines, we started at 5 megawatts and now we are at 15, 16, 20. Now it seems that we are reaching maturity because going to 30, 35 will just bring more complexity without much gain in size. But we are not there yet for cargo vessels. I mean, you discussed, Laurent, about the project of crossing Atlantic with 500 TEU containers, but the latest developments are reaching the 1,000, 1,100, maybe 1,200 containers sailing ships. So everybody will try to push the limit to have economy of scale, but will be like a 3,000 TEU or 5,000? Maybe we should think more in impact, environmental impact of containers being transported, and maybe at some points a smaller fleet might be more flexible also to capture the change in the market. I mean, it's very nice to have very large flow of containers when the market is booming and constant, but at the moment that the demand drops, it's a kind of panic to get 20 or 25 boxes on large container vessels. So they are currently now starting to slow down speed because it's difficult to get these ships filled as well, and there will always be some fluctuations. So on one side, I mean, I don't think that one concept will kill the other, but I'm not sure that the let's say the quest for more giant and larger might be logic when you bring all the type of requirements in the transport chain in general. So maybe smaller ships might become more efficient from an environmental point of view as well.
If I could, I think that ships have already reached the limit of size, and because of both supply chain issues and the conditions at ports around the world. And I think for my perfect example is New York. The New York port raised the Bayonne Bridge to accommodate post-Panamax ships, and only one has ever showed up. So somebody spent billions of dollars to accommodate one large ship that really never showed up in the port. And those are the kind of things we have to take into account as we go forward. I think a fleet of moderate sized ships that are significantly more, with more mariners, more cargo surveyors, more longshore jobs, less energy used, more shipyards at full capacity is a much better solution than significantly larger ships to deliver cargo. And also, let's face it, we don't need a lot of this stuff, and we don't need it moved from place to place. So maybe part of the way we reduce carbon is by just not importing some of this crap from places far away and start making more things locally with our own resources and growing more food locally and being very better caretakers of our regional environments. And I think that conferences like this are really important to get that word out, and especially when we're doing it with student naval architects and others interested in the maritime professions. So size is not always the answer.
If I may add to that, without thinking about what the ship size should be, if you look at case studies, I'm not sure what you would call a moderate size ship, but when we looked at, let's say, a 200,000 ton bulk carrier, and you are looking at mainly the active devices, talking about wind propulsion, so flattener rotors and suction wings. If you want to maximize the energy savings through wind propulsion, there is presently a limit of what is available in the market. And I think the main factor here is industrialization, that the suppliers, they need to make sure that they have a standard product that is fully certified, where they have also the production facilities. And for the moment, with the relatively low volume of systems up until now, it seemed they have focused on the sizes, well, for the flattener rotors up to 35 meters so far. If you put that on larger ships, devices with that maximum height, and you want to achieve large savings, you have to put many of them. A case study that I just mentioned as Marin, and there have been others as well, presented at the press conference. Send me a note if you want to have the reference. Shows that when doing that, the cost is not so favorable. And actually, if you look at economic payback times with the linear cost increase assumed for fitting each additional device, but then aerodynamic interaction effects starting to play a role, which is generally generating losses. So every device doesn't add the same percentage saving. You're tempted towards the lower number of devices, meaning less percentage savings on emissions or fuel cost. And for that reason, I think there's a need for larger devices. And that means that the suppliers need to catch up and to move their industrialization process to larger devices. And I think there's no hard limit there. But they have to, of course, gain back their investment in doing that process. So they have to see the market. And I think when we see more installations, then they will probably bring out new models, larger, following the path of the wind turbine industry, probably.